All right, so notes. Do we title them? Polynomials, linear functions, and zeros. So we got our notes titled. Titling our notes that we are doing. Now, just because I'm recording doesn't mean you can't ask questions, by the way. Just so you know. And they just heard that, and that's okay. And when you take long times to write, I pause, too. All right. This slide. Do you really need to write each polynomial factor in factored form means to factor it? No. You just need to know that if it tells you to give something in factored form, you're going to take it and you're going to factor it. And you're going to factor it down to as much as you can possibly factor. On tonight's homework, the very first problem, it's very obvious that you can factor out, I don't remember if it's a number or a letter. I'll tell you in a second because it's a letter. But then what's left inside the parenthesis also factors. So it's very important to realize just because you GCF'd something does not mean it doesn't factor more. Then in your homework tonight, you're also asked about multiplicity. They ask you to tell you what the multiplicity is of something. That's how many times a number is a zero. Not meaning the number is zero, but it's considered a zero of the function, because remember we talked about zeros of the functions are where it crosses the x-axis, right? It's those points of intersection. So it's the number of times it happens. So we're going to borrow Colin's book for a second. Thanks, Colin. Glad you have one out. See? Colin's very helpful to us. So,
what?
All right, so ladies and gentlemen, this is a problem in tonight. Well, this is not. I took an even one. So it looks like this, and it wants you to tell the multiplicity. So the first thing you're going to do is you're going to set each factor, this is a factor and this is a different factor, equal to 0. How many of the x minus 1 parentheses do I actually have?
3.
3 of them, yes. So that's really x minus 1 equals 0, x minus 1 equals 0, x minus 1 equals 0. No, he's not handing out gum. Knock it off. How many times does the 0 show up? 1, right? So that has a multiplicity, and I don't really want to write that all the way out. 1 of 1. It happens 1 time. That's 3. How many times is that 3? I mean, not that 3. Good job, silly girl. How many times does the 1 show up?
3.
So that has a multiplicity of 3.
So it's just how many times?
It's how many times it is an answer. It is, but it's a big word for something that's pretty simple. So that's what multiplicity is. Multiplicity is how many times a number is considered a, quote, 0 of a polynomial function. We good?
Yes.
Moving onward?
Yes.
Nope. Still writing?
1 second.
1. All right. All right. I'm going to pause it for a minute while you guys copy all of this down. All right. So part 1, first step. We're going to take the x plus 2 and set it equal to 0. We're going to take the x minus 1 and set it equal to 0. And we're going to take the x minus 3 and set it equal to 0. To actually now find the 0 of that function, I'm going to subtract the 2 to the other side. So I get x equals negative 2. I'm going to add the 1 to the other side, so I get x equals 1. I'm going to add the 3 to the other side, and I'm going to get x equals 3. These right here are the zeros of that function. And if we had a guess right now, we're going to take a wild guess. What kind of function is this? No, that's 3 terms. Is it a linear? Is it a quadratic? Is it a cubic? Is it a quartic? It's a cubic, right? And we're going to talk about that more in a minute. All right, so at this point, I go ahead, even though I know it says to sketch the graph at the end, I start plotting my points as I get them. So I'm going to put a negative 2 on my graph, I'm going to put the 1 on my graph, and I'm going to put the 3. Step 2 says find points for x values between the zeros. That means I need to find a number between here and here, an x. So between here and here, you need to pick an x, plug it in, and get the y answer. And then I'm going to do the same thing here. You could do the middle, but do you want to deal with fractions? No, right? But what could I pick? I can pick -1 or I can pick 0, right? And what do we all know? What's Mrs. Miller going to pick? She's going to pick the 0. So y equals 0 plus 2, 0 minus 1, and 0 minus 3. So when I do that, I get 2 times -1 times -3, or I get 6. So 1, 2, 3, 4, 5, 6, right there.
Wait a minute. Mrs. Miller part of the rule. How'd you get 0 plus 2, 0 minus 1, 0 minus
Because she plugged in 0.
I didn't ask you, Dave.
I answered it. She plugged in 0 for the X.
I did. He's right. I plugged in 0 for the x. So now we're going to do it again, but we're going to do it between these 2 points. And so I'm going to pick 2. I'm going to plug a 2 in for all my x's. So I'm going to get y equals 2 plus 2, and 2 minus 1, and 2 minus 3.
Wait, where'd you get the 2 from?
Well, does 2 not fall between -1 and 3?
And then that's the 0 fell between them.
So I'm going to plug this in, and that's 4 times 1 times -1, or -4, and that's down there. So step 2 is pick an x value that falls between your zeros to find another point. In other words, what I just was able to determine was this point is up here, so this graph is up, whereas this is down low here between it's in the negatives, this guy's up in the positives. Step 3, determine the end behaviors. To determine your end behaviors, I need to know what this variable times this variable times this variable is. X cubed, right? Because an x times an x times an x is an x cubed. And all of those x's were positive x's, so it's a positive x cubed. So based off of what we learned yesterday, if a is positive and n, which is our exponent, is odd, what are the end behaviors for a positive? Odd. Starts down and ends up. So this graph is going like this.
What are they? Like, it doesn't have anything to do with that doing math. Because I was trying to explain to somebody and I was really confused. The thing that you determine if it's a monomial, binomial, what are they called?
Those terms? Okay. Like, yeah, we're talking about terms, number of terms.
That's all it-
Okay. Anybody have a question over how to graph this? You won't be heard on my mic, just unless you're really loud.
You can pick any point in between the 2 points.
Yes. So I could have picked a fraction or a decimal. I just don't want to deal with them if I don't have to.
You picked 0 on the first one, right?
I picked 0 because 0 was a whole number point in between there. Actually, an integer, really.
Okay, so you could have picked negative.
I could have picked -1.
2 on the other one.
It was right. Because I'm looking for an integer, a whole number, positive, negative, whole number, that will, because they're just easier to deal with,
Now, if
is
they're-
why I picked.
Now, if they're like, will we ever see a graph that's like,
Yeah.
like that?
Yeah.
And they're not on a specific point?
Yeah.
So how will we figure out if?
You would just have to pick some kind of decimal. I mean, if I wrote down 0.7 and 0.8, and you had to pick something in between there, you'd pick 0.75
Yeah, but what if like?
and plug it in.
Just say the 1 and the 3
Uh-huh.
were right on the 2. How would we know?
If both these guys were right here,
Not in the exact same spot though.
but they're on either side of it.
That was a bad example. What if they're in the middle of 2 and 1?
Yeah, so,
Right.
right. So that's what I'm saying. You would just pick a decimal that's bigger. I mean, and smaller. So
Oh yeah, because you know the value of both. I got it.
right, right. So you can pick something. Okay.
Wait, why do you have an x to the 3 up there?
Because it says determine the end behaviors, which means I got to multiply those x's together, and that came up to be x cubed. So that's how I got my positive and my odd. All right. What happens now if I tell you to graph this, and it's not in factored form for you already? You've got to do the factoring. All right, so the first thing I'm going to do is factor it. Between the 3x and an x cubed, what do you notice? What can I factor? How can I factor it? And they both have an x in common. So I'm going to take and I'm going to GCF this. So I get 3 minus x squared. I'm going to set it equal to 0. So I'm replacing the y with a 0. I just like to throw it on the back end. So I have to set each factor equal to 0. And since I have multiplication here going on, this is a factor, and this guy here is considered a factor. So I'm going to take the x and set it equal to 0, and I'm going to take the 3 minus x squared and set it equal to 0 as well. X equals 0, I don't have to do anything to it. It's finished. It's done. We know that x equals 0 is one of them. This guy here, if I add x squared to the other side, I get 3 equals x squared. How can I get that to be x? Say just x. Take the square root of both sides. So if I take the square root of both sides, I end up with square root of 3, by the way, is plus or minus, positive or negative answer, 1.7. So on my graph down here, I have a 0 at 0, I have a 0 at 1.7, and I have a 0 at negative 1.7. So I've now put those zeros of the function on the graph. And just like on the last slide, I need to now pick x values that are between them. So I need an x value here. Yeah, I'm going to go with 1, which is right there. And I'm going to go, negative 1, and I'm going to go with 1, which is right there. So they're between.
Question.
Yes. I don't know.
Oh, why would you add x squared to the other side?
Because I need, so that I can take the square root of both sides and know what x equals. Too hard to factor. I could do completing the square on it, but that's also more work. Or I could have used the quadratic formula. Also more work than I wanted to invest into that problem when I could just add over and square root. Okay? All right, so I plug in the negative 1. And negative 1 times 3 is negative 3. What is the cube? If I cube negative 1, what is it?
If you cube negative 1, it is negative 1.
It's still negative 1. So I have negative 1 in this, and the minus sign, which gives me a plus then. So this is negative 2. Okay. Now I'm going to plug in the 1. So this is 3 minus 1, or 2. Now, let's go back.
Wait.
Might have, and all the giggling going on back there. So I have a minus x cubed. So what's my a? It's just the negative, right? It's the minus 1. So it's a negative. So we know a is negative. My exponent is even or odd? Odd. What's a negative odd?
Negative odd. Down, down. Up, up.
Starts up and ends down.
Wait, what's the purpose of those two little purple?
To show you that those are the 2 points that I'm going to use to plug in. Those are my 2 x values I'm going to use to plug into my graph, into my equation, sorry.
Arrow.
Those are arrows. Those are not points, they're arrows.
Why? Oh. So you get a plus minus, you have to put it on both sides, and then I get it. Yeah.
Okay. So you will have some that are already factored for you that you're going to have to do. You're going to have some that you're going to have to factor to graph. And last but not least, you're going to have some where I give you the factors and I want you to give me the equation. So this is the steps for you taking those zeros and making an equation for me. Let's finish this up. So first thing I need to do is say x equals negative 2, x equals 1, x equals 4. Many of you will be able to very quickly not write this step or the next step and go straight to the third step. I need to make each one of these say x equals 0. So to make this one, the first one say x equals 0, I need to add 2 to the other side. In case of the second one, I need to subtract 1. In the case of the last one, I need to subtract 4. I then am going to remove all those equal zeros, and I'm going to put this together. Okay. And now I multiply. So if I multiply the first two parentheses together, that's x squared plus x minus 2. Now, for many of you, I just skipped a step on you because I multiplied it out in my head and added combined the middle terms. So you get a plus 1.
So you're like foiling?
Yeah, you foiled. I know that if I take this guy here and this guy here and I combine them, I'll get my middle term. I don't need to, so I don't write it down usually. All right, I'll go ahead and write all those steps on the next one. So I'm going to take the x squared times the x, and I'm going to get an x cubed. X squared times the minus 4, I'm going to get minus 4x squared. Now you can continue this out in one long row, or I'm going to do it the other way that I do it, which is x times x, and I'm going to stack them. Is x squared, x times the minus 4 is a minus 4x. Last but not least, I take the negative 2 times the x, and that's negative 2x. I take the negative 2 times the minus 4, and I get a plus 8. I add this all together. In other words, I add combine my columns. And that, ladies and gentlemen, is my equation in standard form, except that right now it's not an equation because I need to put a y equals on it. And there it is. Now, as I said, when this is not a big one, so going out in one straight line like I did here is fine. As they get bigger, I find personally stacking them makes it easier for me not to lose like terms. But you can do it any way it works for you. Questions, comments, or concerns? Yes.
Is the homework super long?
Is the homework super long?
I mean, that depends.
It depends. You have the odds, so you're not doing them all tonight.
How much you can do, depends on how much you can do mentally.
Like what numbers?
7 through 33.
Just odds.
Just odds tonight. Which means
14.
there's 14 problems for tonight. And it's each different piece. Are we good? Yeah, Colin.
That clock is 1 hour back.
Yeah, I know. All right.